So, hello and welcome to our third part of our webinar series. Today we cover the topic of Dunkermotoren for EtherCAT. And here I would like to give you a focus, first of all, on Dunkermotoren EtherCAT products. Which products do we have? Dunkermotoren EtherCAT features, which are the motor features that we support. And in the third part, I would like to give you insight on commissioning. And here, my colleague Alex is already waiting to show you how easy commissioning is with an EtherCAT controller. My name is Michael Burgert. I'm product manager for integrated motors from Dunkermotoren. And yeah, let's start with the product overview. We have a product range of 20 watts continuous output power and up to 1100 watts continuous output power and a peak power of nearly 4000 watts. As you can see here on this image, we have only a part, but actually the most important and biggest part with integrated control electronics ranging from BG45, 91 watts, up to BG95 with more than 1000 watts output power for smaller motors, and also now for brush type motors. We have we have the BGE 5510 for motors like GR42 or GR63, very popular motors, and there are many applications where also this combination works. Not only the motors is what we offer, but also gearboxes, warm gearboxes, Spirotech, and also a wide range of planetary gearboxes. And on the rear side from the motor, we also offer brakes and different types of encoders. So what you see here, all the components are designed in Dunkermotoren, all in the same, even in the same building, right next door to door, which is really a big advantage because the components like motors, gearboxes, and brakes, they are really designed to fit to each other. So they are designed by engineers that sit next to each other, and they know exactly how to adjust all these components together. The functions of the D-Pro EtherCAT motors are, in general, it's an EtherCAT slave. We can open over EtherCAT, and we cover distributed clocks and operation as NC axis. And this is what Alex will show you afterwards in the practical part, how to set up this NC axis. The third of these possibilities, the distributed clocks, is something that is new. As you probably know, we've had EtherCAT in the past, but this was basically just a translator between the can open part of the motor and the EtherCAT part on the other side. So there was some translating component. The new D-Pro EtherCAT does not need that anymore because it has direct EtherCAT communication, which makes it much faster, and the distributed clock enables us to be part of the real-time world. So we now, with this D-Pro EtherCAT, have real-time communication. This means the distributed clocks that you have in each component, you have an individual clock, and with this, the controller can compensate basically even the way between the controller and the single components. It sends a command, and all the devices start synchronously at the same time. So this is real-time servo, and this is what we support. We support integrated and external control electronics, as shown on the previous slide. We support field-oriented control with a high-resolution encoder, which helps you, especially for battery-operated applications where high efficiency is key. And here, field orientation control helps to save energy, but also to reduce the noise to a really low level. We support interpolation mode, jerk optimized ramps, and as a standard, we have safe talk off for all D-Pro EtherCAT motors and external controllers. Then we support IIoT functions, which gives you the opportunity to collect data in a defined way and use them for analyzing and, for example, for predictive maintenance. Motion code is a possibility for you to write your own software onto the motor. And with this software, you can run your own program, collect data, analyze the motor functions, and send the data out, which also gives you far more possibilities to make the processes, the internal data inside the motor more transparent and send it out through EtherCAT. Motors with EtherCAT always have in general the option for an SSI interface, and with this interface you can either send out high resolution signals from the internal encoder, or the other way around. The motor can read high resolution encoder signals from external encoders. Now, how do you get your motor, motor that fits perfectly to your application? First of all, we show you the selection in our catalog with all the main data. Then you can go to the internet and have your gearbox and brake configured to the motor. And for more detailed information, you can have a look in the function and connection guide, where you find, for example, all necessary information for cabling. Once you've done that, the commissioning part starts. Here we have a starter kit, or to be more precise, several starter kits for different motors. And with these, you find the ESI files, you find the parameter description, and what's the last four items on this list is called Let's Connect, which is the commissioning help. In the parameter description, you find detailed information on all the parameters that our motors have. It's more than 500 parameters that help you to really fine-tune all your application so that you can fit all the components best to your application. Then the Let's Connect commissioning guide is a step-by-step description of all the steps you need to do from basically after you connected the motor until the motor runs, until the motor is tuned and perfectly integrated in the controller. Once you've done that, your application runs, hopefully forever. And yeah, the first part will now be shown by Alex. How does it work? How does it work in practice to commission a motor, a D-Pro EtherCAT motor, to a back-off controller? We have a back-off PLC connected to a commissioning PC that runs with TwinCAT 3 and a EtherCAT EK1110 EtherCAT interface. And on the motor side, we have a BG95 D-Pro EtherCAT that we now, or that Alex now will get running and show you how that works. Okay, questions, please, after Alex has shown you the commissioning part, and then we can you can at any time afterwards ask us questions or write them in the chat. Okay, so Alex, it's your turn. Please have a go and show the commissioning part.
Thank you, Michael. My name is Alex Haberstroh. I'm application service engineer here at Dunkermotoren now since over 3 years. And I'm responsible if you have some problems with commissioning or running our motors, then the chance is quite high that I will help you. As Michael already said, we want to connect our motor now to the TwinCAT system and want to run it via TwinCAT. And first we want to have a look into the starter kit, how you get it from our homepage. If you download it, you can get these files. And here you have the Let's Connect's two versions, Quick Start and NC access. So for those of you who know what Quick Start means, we can also run the Quick Start functionality on EtherCAT side. Like on Profinet and on Ethernet IP, it's always the same. But today we want to show you how easy it is to integrate the Dunkermotor into an NC axis. And let's have a short look into the Let's Connect. So if we open it, the first thing we see is what the LEDs are doing on the motor. And then it's already starting step by step to integrate it into your TwinCAT system. First step, of course, is to import the ASI files. I have already done this step on my PC, so I will skip it. And the next step is to set up the connection between TwinCAT and the motor. I have here an empty project in config mode running, and now I will scan for devices. I will find quite a lot of devices here because there is some other stuff connected to the PLC, but as last step, we will find the motor. So we see here it already detects that there is an EtherCAT drive, and it asks if it should be added as NC access. And of course, we want to do this, so we click OK and activate the free run mode. And now we see here, drive 9 is our motor called. If we open it, we already see that it's linked to something here. And if we open the NC axis over here, we can see under settings that it's linked to drive 9. So it's done automatically via the ASI file, and it works fine. So you see here that it's connected as DS402, can open access type, anything fits already. Anything is linked correctly, and this is what the next step is in the Let's Connect, is to check if anything is linked correctly. And of course, there is some process data predefined. It's possible to add here a lot of stuff, but in the basic package, like now, it's just what we need to get the NC access run. For example, you could add here some parameters like the actual temperature or whatever from the motor into the process data. It's described in the Let's Connect how to do this, but I will skip it today and just go on. Then we have the opportunity here under startup to add any parameter we want to add into the startup list. This is always written to the motor when the connection is enabled between motor and PLC, and then it gets initialized. For example, you could add here something like the current limits or whatever. You can find all parameters in the parameter description, like Michael already said. Let's have a short look here. Here we can find all Dunkermotoren parameters, and down here we can find all parameters depending to CR402. And if we open one parameter, for example, the current limit, then we always find on the top the index and subindex. which we would have to write, the data type, and so on. And of course, the description of the parameter itself. So it would be quite easy to add here a new parameter. We can choose it already from here. So current limit, for example, for 2 to 1, like this. Current limit, here we can, if we enable this box, it gets written. Then we have to set up the data, of course, and then just click OK, and it will be written on every boot up of the motor. I just cancel it now, but of course, it's also described in the Let's Connect here in detail. Okay, so that's the connection part. The next step is to set up the NC access, because this is something we cannot do inside the EASY file because it's application depending. So the first step is to choose the unit you want to choose. I will take degree today. And then you have to tell the axis how to calculate the motor parameters or the motor units into degree units. So first step is to set up the unit itself, and then we go to the encoder parameter. And here in the scaling factor, we have to tell how many degrees are how many counts on the motor. It's quite easy. In my case, I don't have a gearbox, so I have 360 degree. And in this time, the motor gets 4096 counts, single turn resolution, and that's it. If you have a gearbox here and want to scale the gearbox, you just have to do it here. For example, if you have a gearbox with the ratio 10, then just type in here 36 instead of 360. Next step is, so this is for the positioning. The next step is the parameter, how the velocity, the target velocity has to be scaled inside between PLC and motor. So we see it here, it's described in the Let's Connect. And it's always the, oh, it's in German here, I see, we have to correct it. It's always 7520 divided by the single turn resolution of the motor. In our case, it's 4096, and the factor is 1.836. So we just have to fill it here, 1.836. And now if the PLC says run with 100 RPM, or in this case, I don't know, 36,000 degree per minute, the motor knows how to deal with this value. Okay. Then we have to set up some time compensation. This is optional, but it makes the controlling a little bit better. So we type in here on with velocity, and I think it's 1 here and 1 millisecond here. And in the drive, we can do it as well, on with velocity, but we don't have to change the values itself. Okay, so we have the time compensation and the calculation. Now in the axis itself, we have also to set up some parameters, and therefore especially the reference velocity and the maximum velocity. It's depending on our calculation. If you have done the scaling with a gearbox, you have other values than me. For me, for example, with 360 degrees per revolution. I have 24,000 degrees per second. It's the same like 4,000 RPM on the motor. So I will type in this value also as maximum value. Of course, if you have typed in here before at the encoder something other, you have to rescale these maximum values here in the same way. The second thing we have to set up is the monitoring, I think. Yes, the positioning window. That's the point when the controller says now the motor is not doing what I did tell him to do. And of course, we have to set up a realistic value here. Let me just have a look into my papers. Yes. So we have to set up this one. And we always set up a half motor turn. In my example, it's 180 degrees. If you have a gearbox, it could be 18 degrees, for example. So it's always a half motor turn without the gearbox. Okay, and now all parameters are set up, and we can activate the configuration on the controller and restart in run mode. Okay, it worked. We see here the online values. And now we can already go online in the online function of the axis itself, set the enable signal, and run the motor. As you see, the position is changing. And I'm also able to run positioning. I'm not sure if you can hear the motor, but you can see that it's running here. And now you can control the motor like any NC axis in the PLC, and it behaves just like any NC axis in TwinCAT. Yeah, that's it. It's quite easy to run our motor in NC axis. It's more or less some calculation if you want to set up your units of your application, and then you just type in the values and run it. Okay, so that was the practical part, Michael. And yeah, I think in the end, if you now have some questions, you can just type them in the chat. We will answer them in the end.
Okay, just one more note regarding the setup. We have here the one where you have a commissioning PC that communicates with the back of PLC, and this one communicates with the motor. If you want to have direct link between the commissioning PC and our motor, this is also possible through Drive Assistant 5. Here you can have tuning functions and also oscilloscope function, and you can address all the parameters directly. Now, important to say is that this works not while the motor is in operation with a PLC, because the EtherCAT does not allow two masters in one system. This is why you need a different setup. You need a one-to-one setup from the commissioning PC with Drive Assistant 5 to the motor. So this is also possible. You can do tuning in the application and then get the connection, established connection with the EtherCAT network, and then run the motor accordingly. Okay, this was it. As Alex said, please write your questions in the chat or open the microphone and ask directly. So now would be the time. You, of course, can also get all the information from our website, our product portfolio. And if you have any further questions, please ask myself for the products and or Alex for application and service, particularly commissioning. I'm looking on the chat. No questions so far. Alex, anything to add?
No, not from my side.
Okay, so I thank you very much for your attention. As we said, please questions or at any time. If not, I wish you a good rest of the day and see you next time, hopefully. Okay, goodbye.